Problem 35 of chapter 4 of Giancoli 6th edition. So we have two boxes on a frictionless table and they are connected by a cord, and now this time this is the only problem that we are solving with a cord that is not a massless cord but is a heavy cord that has mass 1 kilogram. Okay, so I have two boxes. One here, I'll call it the box B that has mass MB, and here in front I have another box, my box A, with mass MA, and they are connected by a cord, but this cord is not massless now anymore. It has a certain mass. Okay, and we are going to pull the system. Here is the force that we are using to pull it, and we want to know what is the acceleration. So calculate the acceleration of each box and the tension at each end of the cord using the free body diagram. Okay. This is a frictionless surface, so this is good. It's make life easier, but the cord is not massless. Okay. To solve this problem, we are going to draw all the forces on each object. I'm going to choose a reference frame, and this reference frame is positive to the right. Okay. Very well, starting from box MA. Okay, of course we always have weight to take into account, a normal force because of the contact between the force and the table. I'm not going to bother writing those forces now. Okay, so the weight, let me just put one example, weight and the normal force, but I'm not going to bother about these forces because they are not asking us about normal force and there is no friction involved, so normal force is not that important here. All right, so I'm going to focus only on the horizontal forces. Okay, on box A, we have that FP. I'm pulling this box. Now, box 8A exerts a force on the cord. It pulls the cord reacts and pulls it back. So this is the tension that we call tension A in the drawing. Okay, and well, both are the same, just different magnitude. Now, through this rope, we go through it, and then this rope, this cord, is connected to box B. What is it going to do? It's going to try to pull box B, and box B reacts and pulls it back. So this is the tension force B, same magnitude, different direction. Okay, so the question of the problem is, what is the acceleration of box A? What is the acceleration of box B? And I don't need to distinguish, right? If this whole composition of box A, cord, and box B are moving together, now if I don't break the cord, they're moving together, then all of these accelerations is just one. So what I want to know is what is the acceleration of the system. So this is the first question. And okay, so acceleration A is equal to acceleration B, and I'm calling it just A. And the other question is, what is the tension force A and what is the tension force B? The red and the green. All right, so let's write the equations for each box. Newton's law for each box. So I'm starting here from box A. What do I have here? FP minus FTA equals to MA and the acceleration. Before going straight to B, let me go through the cord. What do we have at the cord? We have that FTA minus FCB is equal to mass of the cord and the acceleration. Okay, and now finally I go to the box B, and there I have just one force, which is the FTB, and this is equal to the mass of the box. Okay, to solve this acceleration, what I'm going to do, I'm going to, well, I cannot solve directly from this because I don't have FT. I cannot solve directly from this equation because I don't have FT, I don't have FTA, FTB or FTBA, and I cannot solve from here because I don't have FTA. So I'm going to put one equation to the other. And so first I'm going to put this one here, and from this I can isolate FTA and say that FTA is equal to MB plus mc multiplied by the acceleration. Now I can put this one here, and I have that Fp is equal to ma plus mb plus mca. Okay, so I put this FTA here. This is a negative sign. I put it to the right, and then I have this whole equation. So you see that this equation is basically, I could write it as Fp equals to big mass A. What is this big mass? The mass of the whole system here. So this whole system, I could call it a big object M. Okay. All right, so from this equation here, since I have all the masses, since I have the force that I'm using to pull, I can find the acceleration. Once I find the acceleration, that is very easy. I can go back, find the tension force in B, and use this acceleration either here to find the tension force in A, or into that equation. Either one would give me the tension in A.